Hello everyone and welcome to yet another problem from Geeks for Geeks. Within this video, we'll be looking at one of the problem says root to leaf path sum. The problem is pretty simple. We are provided with a binary tree, and with this binary tree from root node till the end child node, we'll get a number such as 632 and 6357. All these numbers we need to sum it and return it. So we got 632, 6357, 6354 and 654, and hence all the summation of all these numbers gives 13997. Similarly this, and similarly this 112, 12, that means only 12. Well, this boils down to a very simple thing, that we need to get the numbers. The steps are pretty clear then. Steps 1, get the number and store the sum. Getting the number is quite tricky, or I must say is quite prone to error, because we need to get the number and append the new number. So previous number plus current plays a very important role. Append, I'll just say append, and within this we need to just sum. So let's take a sum which will have only one integer. Now this sum is responsible to store the sum. Why we are taking it as an integer array and not an integer? Because obviously we are going iterating it depth by depth, and we need to traverse one by one stack trace, and within doing so we cannot use any integer variable or any value type variable. We need to use a reference type storage. So integer array gives us a very good access to reference type storage. Now once we have a storing solution, let's get the number. How do we get the number? So let's go ahead and use a DFS mechanism. Within this DFS, I'll say, hey, this is my root and this is my sum. But wait a second, we need to track the previous number as well, right? And append the current data. So the previous number, as we are right upon the root, we don't have any previous. So we can say it as 632, we can say it as 0. So our initial element if would be 0, 6, 3, 2, which is not a big issue considering we are passing an integer, because 0, 6, 3 and 6, 3 is one and the same. Ultimately when we'll get this, we'll return this, but that's not now. For now we will be just going ahead and coding the DFS method. So I'll just say void, or I'll say static void DFS node root int current and int sum. Now if I see that here root is null, I don't want it to proceed further, I'll return right from here. But if I'll say hey, if root is not null, I'll want it to take a value and append to it. So I'll just say current is equal to current into 10 plus root dot data. This will multiply it by 10. It means it will make 6 to 60, and it will append 3 as it is. So 60 plus 3, 63. Next time it will be 63, 63 into 10, 630, 630 plus 2, 632. In that way we'll get the number. It might happen we might end up within a child node. That means root dot left is equal to null and root dot right is also equal to null. In that case it's a child node. And what do we do when we hit a child node? When we hit a child node, we know that our number is completed and we need to store it within the sum. So sum of 0 plus equal to current value, and that's it. We don't need to proceed it because there are no left and right to it. We can have an early exit, but guess what, if there is no there might be any left or right. If this is not the execution the control choose to, Then we need to also DFS within the left node. Also we need to DFS within the right node. So I'll be using current sum semicolon. Also I'll be using the right. Now we have both these things, and we are sure the moment DFS completes its flow execution, then we have sum within this variable. So sum will be returning 0. Let's check for any compiler errors. Well, there seems none, so let's submit this. So the time complexity for this approach would be O of n for sure, because we are iterating one by one every node, and the space complexity would be the height of a tree. Generally you can say it in terms of log n. How log n comes into picture, how trees operation works, what are the more ways to work upon a tree. If you wanted to know more, click the video on your right, and I'll see you in the next one.